All right, so in this last part of our pendulum experiment, we want to see if the mass of the bob has any effect on the period. So I still have the original bob set up. It's a large steel ball bearing. But I found in the closet a couple of other bob-like objects that we're going to try. So we have this little cork bob. It's got a very
Wait, hold it still for just a second, so I can zoom in on it. Hold it still.
Yep.
Wait. There we go.
Okay. We also have a small, looks like small aluminum bob, which is less massive than that one. Then we have this, looks like a big, very massive steel bob. And so we'll try all four of these. Now, whoops. So that doesn't work. Now, one thing that I noticed is that it looks like the bob right now is hanging a little bit lower than it was when I first set this up. It's possible we had some slipping of my not very good knots here, so I'm just gonna, out of an abundance of caution, re-measure this. I know our photo game is still working, but I'm going to re-measure the length of the pendulum, and if this is the sort of thing one needs to pay attention to as an experimentalist. And if we had infinite time, we might consider remeasuring some stuff. But let me just see what this is now. So I'm measuring now a length of 70. I'm now measuring a length of about 75.5 centimeters. And let's give it a 0.4 centimeter uncertainty. So it's not immediately clear when the slipping happened during the last round of measurements. So we sort of have an L at the beginning and an L at the end. Hopefully during the actual measurements it was somewhere in the middle. We're going to have to take our best guess there, and we'll just have to analyze the data, all of us, myself included, and see what happened. If I were to think physically about what's going on, right? So my guess is that the slipping probably would have happened in the first run or two. The reason being that, right, if you think about the forces involved, the tension in the string is going to be largest when the pendulum bob is swinging through the bottom, but it's going to be largest when the bob is going the fastest, when it's released at that initial height. So that might be the case, or it's possible that having gone away for 10 minutes, we had some slipping while I was gone. We don't really know, but we'll just have to analyze the data and see what happened. Again, this is part of doing experiments. If we had infinite time here, we're looking, we probably remeasure as it is. We're looking at about let's call it a 0.4 centimeter difference in the in the length. That's still right. So half a centimeter in about 100 centimeters. That's still that's about a little over about roughly 0.5% difference in the length. So I'm not going to worry about it too much. It's not like we magically doubled the length or something. So it'll have an effect. There'll certainly be some uncertainty. We might have to think about how to assign an uncertainty to the length, but let's leave it be. So what I'm going to do to test the length, the effect of the mass, is I'm going to run this pendulum now. I'm going to release it at a small angle, so at 50 x naught equals 55 centimeters. I'm going to retie so I'll do it with this sort of this small steel bob, and then I'm just going to do the same experiment with the other 3 bobs. I'm going to have to untie and retie the string, so I probably can't get the length exactly right, so I'll measure the length afresh each time, and we can think about ways to take the possibly slightly different length into account. I'll do my best to keep it consistent. All right, so I'm gonna just use these photo gates to try to mark the height as consistently as I can. So that's there. I need to lower this guy. Okay. For low, we have blocked, and so the photo gate is doing what we think it should. Make sure that's all nice and tight. All right. This is now small enough that I can do it by eye. Clear my counter here. We still have our clock set at 4 kilohertz. Put that down, or if not, it's 4 kilohertz. I should have written that down for the previous part as well. Okay. All right. Let's do a measurement. I'm going to pull this out to 55 with our small steel ball. There we go. And we're done. Okay. We have measured Bravo. This is a small steel bulb. This is Bravo 4. Bravo for Delta, Hex B for D. All right, so I'm going to do the same thing I did for the last time. I'm going to measure the period a couple more times with this bob, and then I'll retie a new bob, I don't think you need to watch me fumble with strings, so I'll take a few more measurements with this bob. I'll change the bobs, and then we'll check in with each other again. All right. So we have bob number 2, our cork ball here, and let's let us measure the length. We use photo gates as a sort of the fiducial marker, trying to eyeball to the center mass of this. Pretty much have it. So it is, once again, so cork ball, we once again have L equals 75.5 plus or minus 0.4 centimeters. Everything else is the same. Clock is still 4 kilohertz. So let's take a few measurements. Clear our counter. Pull this out to the same x0 equals 55 centimeters, and just go. And that's kind of swinging in a circle. Let me just redo that. Okay, coming. Done. All right, this is now, I have a period of Bravo 1, 3 hex, that's B1, 3. All right, I'll take a few more measurements and then we'll check back in. Okay, so I've now tied on this small aluminum, or as she'll remind you from the UK, aluminium bob. So that's set up now, and we have kept the clock frequency the same at 4 kilohertz. Our counter is cleared. Let's go and measure. Okay, so I'm going to pull. Let's first get the length here. Hold up this meter stick. At the top. Got the one pretty good. Yeah, it's still, well, the aluminum, so this Okay, still have it at 75.5 plus or minus 0.4 centimeters. Check that our photo gate is working. It is. All right. So let's clear this. Pull this out to 55 centimeters and let it go. And roll time. All right. We have now a period of Bravo 50 hex. That's Bravo 50 hex. All right. We'll just do this a few more times, and then I'll let you know what happened. Okay, and now we have this giant steel bob. We're gonna start by measuring its length once again. All right, get this up here. Da, da, da. Length is a little bit longer this time. I would say that's like 75. I had to completely redo the big steel bob. This time the length, let's say that's 75.9 plus or minus 0.4 centimeters. Let me just remeasure that to be safe. Actually, let me call that. I'm going to strike that out. It's actually closer to 75.8. 75.8 plus or minus 0.4 centimeters. All right, so once again, we'll just take a couple of period measurements here. This thing is counter is cleared, clock frequency unchanged. Pull the string out. 5:55 here, and timing. Okay, this time we have Bravo. Sorry, yes, this is the period. Is now Bravo 3, 3 alpha. X Bravo 3 alpha x. Okay, we'll just take a couple more data points and then we'll check back in. All right, so we have now recorded data for 4 different bobs here. And I think that completes our data collection for the pendulum experiment. I haven't had the chance to analyze these data yet. I'll give it to you to analyze, but I'll be thinking about this myself. I think there'll be some interesting things for us all to think about, and I look forward to having some of those conversations with you over the coming weeks. Thank you very much. And thanks again to Jill for her amazing work in helping me film this experiment today.
You're welcome. Bye, everyone. Stay safe and healthy.